In this lesson, we'll learn more about handling runtime events by creating a simple Doodle application. First, let me blank out all of the code that produced the application we just saw running. We'll produce the Doodle application using a runtime touch event listener. So first, we'll type runtime add event listener, and within the parens, we'll pass in for the first argument touch, which is the event to listen for, and then we'll create a method called draw. Above this line, we'll create the method for drawing the lines to the screen. Local function draw, and within the parens, pass an e. And then we'll close our function. At the heart of our drawing application will be a table that holds line segments. We'll need to store the old X and Y position of a line segment in order to use it to create new line segments. So outside of the draw function, we'll create a few forward references. Local old X, local old Y, and then we'll create a table to hold our line segments. Local lines equals open and close curly brackets. In Lua, this declaration creates an empty table. Within the draw function, we'll start with the following. First, we'll need to assign the old X and Y. This is the starting X and Y of our touch. Old X equals either the old value or the current X value of the touch, which is accessed through e.x. We'll do the same for the Y. Old Y equals old Y or e.y. So in Lua, we're saying that old X is equal to itself, or if that's not true, it's equal to the X property of the event object, which here is the X position of the touch. The same is true for old Y. Now, we'll create an instance of a line. Local line equals display.newLine. For the arguments, we'll pass in old X, old Y, and then e.x and e.y. So here we're creating a new line that starts from the old X position and moves to the current X position of the touch. The same is true for the Y. Let's take a look at the result. Nothing happens yet because I need to set the color of the line and the width of the line. So we'll go back and set line, set color, and we'll make the line black. Then we'll set line.width equal to 3. So here you can see the new line segments are being drawn, but they're being drawn from a center point. So the key to getting the appearance of a fluid line is to append different line segments to the lines table. Within the draw function, we'll do the following. Lines, then with brackets, we'll type $lines plus 1 outside of the brackets equals line. What we're doing is we're adding a line segment to the lines table. Within the brackets, the hash sign next to the word lines represents the length of the lines table. By adding 1, we're basically saying that add to the end of the lines table a new line instance. We'll use this technique of appending to the end of tables a lot throughout our lessons. Finally, the last thing we'll do is set the old X and old Y to the current position of the touch on the screen. Now we'll go back and draw. One problem with our current code is that if we wanted to draw a new shape or line, it will be attached to the previous line. So we'll add some code to the ended phase of the touch that will allow us to create a new set of line segments. We'll go back to the code, and underneath old X and Y, we'll type if e.phase ended, or e.phase cancelled, Then old x equals nil, old y equals nil. So this will reset old x and y at the end of each draw cycle. Head back to the application and draw. If we wanted to clear the entire screen at the end of drawing, we can write the following in the ended phase. For j equals the total number of lines, which is represented by # lines, comma 1, comma -1, do end. So here in Lua, we're saying for j equals # lines, or for j equals the total size of the lines table, until j equals 1, which is the second argument, and in reverse order, which is the third argument, -1, do the following. Lines j, colon, remove self, lines, bracket, j, equals nil. So take the current line segment in the lines table and call its remove self method. Then set that table entry to nil. The reason that we're iterating through the lines table backwards is so that we don't throw any errors by removing positions that are ahead of others that need to be removed. We'll be often using this method of reverse iteration to remove objects from tables. We'll save it and head back to the simulator and take a look. So we'll draw a shape, and as soon as we let go, that shape is gone. Of course, if you wanted to, you could implement some kind of button that does the exact same code and references the lines table, but we won't do that for now. And this ends our lesson on handling runtime events.